All right, so 1.4, thinking about valid arguments. So, this chapter we're just starting to lay this idea of deductive reasoning and how we justify arguments to verify they're true or valid or invalid and so forth. And so it seems like it's just really about logic, is really what we're looking at here. So, as we dig into, these are just other ways that we can prove the validity of our arguments that we have in front of us. All right, so starting us off here, an intro. So going back and looking at this, so deductive reasoning, as a reminder, is an example of deductive reasoning we have here is if Daniel studies, then he makes an A. If Daniel makes an A, then he makes the dean's list. Daniel studies, therefore Daniel makes the dean's list. So just kind of working our way through this sequential process to deduce that this outcome, this therefore he makes the dean list. Remember a couple things here, that when we are looking at these arguments, we have a set of two or more statements are called a premise. So in this particular example right here, these guys right here would be the premise. And then this guy right here would be the conclusion. So give me 1 second. There we go. All right, so valid argument. So reminder, this is review from our last section. So an argument is valid if the conclusion is true in every circumstance that the premise is true. So remember, conjunction is an and. So when we go back and kind of review, so we have an and statement right here. So no matter what it is, if we have this conjunction, we're going to show some symbols here in just a minute. So we have, we're saying that, let's just go back for 1 second. So in this case right here, remember this was the premise, right? So if these guys are true, all of these are true, and that's true. So a true statement here and a true statement there will lead us to a valid argument. All right. Invalid argument, in some cases, the conjunction of the premises is true and the conclusion is false. This makes a valid invalid. This makes the argument invalid, excuse me. So invalid arguments are sometimes called fallacies. Note that a valid argument may have a conclusion that is false if only one of the premises fails to be true. All right, so just kind of that whole thing about when we're looking at these premises here, so go back here and we look at this first example, this premise right here has 1, 2, 3 statements in it. So if any of one of those statements is false, then overall we might have a false on that situation. All right, let me get that taken away. Oops, clear, there we go. All right, so arguments. Arguments will often be written symbolically. So the cool thing about writing things in symbols is then we can go ahead and use truth tables. So that's kind of the whole idea. So we introduce a new symbol here, therefore. So we have the word therefore here. And so the 3 dots represent therefore. So in this case, when we jump into this, what's happening is that we have an if then. So this is if P, then Q. And that's the same thing here. If P, then Q. P. Sorry about that. So those are our 2 premises. This is premise number 1, premise number 2. All right, and then therefore we have Q. So therefore Q. So if P, then Q. So if that's true, then, or the next thing is and inflation occurs, therefore the price of automobiles go up. So it's just a sequential thing that we can get. So we can use these. Kind of the cool thing about this is that we can kind of use these as we're solving. So let me having a little trouble with technology tonight. So here's an example of the rule of detachment with the truth table. And so you can see how we break this down. And so the whole idea is that this is a premise right here, right? So we have, we have premise. So we put them together. So a premise and a premise is equal to this premise, which is true. And in this case, Q, the outcome, is also true. If we do the next one, and that was P implies Q, that gives us true. but then our P is true. Oh, wait. Let me hit pause for 1 second. Sorry, I was second guessing myself. But the problem is that the conjunction of our premises, so that's this step right here, the conjunction of our premises is false compared to our conclusion. That's true. And then we have a false conclusion and a false premises. So the whole idea is they both have to be true to be able to make it a valid statement. All right. So let's determine the validity, of the following argument. If John is a, well, I have a problem there. All right, there we go. We just had one. I had one word wrong. So if John is a thief, then he is a lawbreaker. So that's our first premise, right? So that's the if P then Q. Then John is a thief. John P. Therefore, John is a lawbreaker. So if P and Q, therefore P, or we put those together, if we made a truth table, we would see that. Now, this argument is valid because of the rule of detachment. Observe that because we recognize this previously established pattern, we do not have to have a truth table to show this argument is valid. So we've already shown that this particular scenario where we have the if P then Q then P, NP, is therefore going to be equal to Q. So we've already proved that back here. So then we can just continue to apply it. Even though it's a slightly different argument, it's still the same formatted argument. So therefore, the rule of detachment allows us to say that. So if you have something set up like this, where you have if P then Q, P, therefore we can go ahead and say that it's Q. All right, so the chain rule. So another often used pattern of argument which can be stated as a theory and proved by means of truth table is called the chain rule. The truth table on the next slide verifies that this argument is valid. Observe that in each of the 4 cases in which this conjectures of the premises is true and the conclusion is true. So in the truth table, we come across and we see that we have our conjunction. So we've got premise and premise put together. So that's true. By building the table, we get across true. And then we have the P implies R. So as we build the truth table, we build these out to show that conjunction and conclusion true, conjunction, conclusion, conjunction, conclusion, conjunction, conclusion. So in this particular case of the chain rule, we get 4 different pieces applied. Oh, looks like I messed up that, but we'll just roll with it. All right. So cruising right along. So here's an example of the chain rule. So if a woman is a good speaker, then she's a good teacher. If a woman is a good teacher, then she's a friendly. If a woman is polite, then she is polite. And if a woman is polite, then she is well liked. Therefore, piecing that together, we get our P implying our T, our last piece there. So remember, this is called the chain rule, and we're going to chaining it together. All right, rule of contraposition. So remember, the contraposition is where we negate. We replace the P and the Q, and we negate them. So with the rule of contraposition, what we see is that if we had this scenario come up in this particular symbol box right here, then we know we have a true statement. Oh, here's an example when it's not valid. So if someone is a college student, then he or she is intelligent. So right there, we kind of got the breakdown. Juan is intelligent, therefore he's Juan is a college graduate. We will examine the validity of this argument by constructing a truth table. So let's take a look. All right, so going back just real quickly, remember that we had if P implies Q, and then sorry about that. If P implies Q, and that's conjuncted with just the Q, and when those are true, then in the conclusion's true, we have a valid statement, or argument, So the only time that happens is down here. Now, in this particular case, because what we're comparing is we're comparing the conjunction with the conclusion. So I'm gonna hit pause again real quick. I think I left something out. All right, sorry about that little break there. I was kind of like stuck for a second. I was trying to sort through what what was going on here. And then I realized that the actual statement we're looking at is, if we take what we're saying here, I lost my pen. Oh, there it is. So we take what we're saying here is that this would be P. Let me get my pen. There we go. So this is P, right? And that implies Q. And then that would be Q. And then this would be P. So when we look at this, what we're saying is we're saying P implies Q. So we're looking at this guy right here. So any one of these. And then we say Q. So then we're comparing it with this. And so we get P implies Q and Q. So then we're looking at, that's got to be like a true statement, right? That's this. So it's like true and true, right? And that gives me true. Or true and true, and that gives me true. All right. And then the outcome is P again. So in this case here, it is, so in this case here, remember, we're looking for a not valid example. So we do have a valid situation here, and that would be across the top. But this particular scenario here, we can find a value invalid statement or not valid statement right here, because we have the conjunction is true, but the outcome is false in this particular case. And because of that, that makes this a not valid statement. That idea of Juan going to college. We don't really know that. And we can deduce that. We can say, well, that doesn't have to be. Just because he's intelligent doesn't mean that he's going to go to college, whereas the other examples were slightly different. All right, so that wraps up 1.4. Hopefully this helps you get through. Thanks so much.